We're going to go through and review Unit 2, Seafloor Geology. The first thing that we talked about with Unit 2 was the basics of how we got our continents to where they are today. We talked about the continental drift theory, which was proposed by Alfred Wegener. And basically, scientists at that time said, nope, that's not right. You have no basis for your theory. And so they kind of dismissed him for years. So it wasn't until the 1950s when scientists started actually taking over and using military sonar to map out the ocean floor that they realized that the entire surface of the earth is broken up into plates, not just the continents themselves. So that's our major difference between our continental drift theory and our plate tectonic theory. Continental drift says that the continents moved. Plate tectonic theory says that everything moves. All right, and that takes us into really what we talked about with seafloor spreading. So the idea of seafloor spreading is just the idea that new seafloor is being created at all times. So at these mid-ocean ridges, which are our largest geologic features, we've got one in the Atlantic Ocean, the Mid-Atlantic Ridge, and we've got one in the Pacific Ocean, the East Pacific Rise. These mid-ocean ridges are actually a divergent boundary, so the plates are pulling apart, the magma is rising up, it is super cold water down there, so it's hardening, it's cooling, and it's forming new seafloor. Scientists then, further on, went on to come up with this idea of magnetic anomaly bands. And this is just the idea that Earth's poles actually change directions every so often. And there is no rhyme or reason for why this happens, how often it happens, but it does prove once again that the seafloor was not created all at the same time, that it is constantly being created and constantly being recycled. So the rocks nearest to a mid-ocean ridge are our newer, younger rocks. They have less sediment to them. The rocks further away from the ridges, closer to the continents, are our older rocks. They have more sediment to them. They are less rigid. All right, we can see here in our diagram, same thing, it is pulling apart at our mid-ocean ridge. We've got our rising magma. It's coming up, it's hardening, it's cooling, and it's forming that new sea floor until it is pushed out to these subduction zones at our continental margins and is being forced down in our trenches. So a few seafloor features that we do want to review are abyssal plains, so our largest seafloor feature covering a good chunk of our ocean floor, a flat area. Seamounts are underwater mountains. Our trenches, we just talked about being a subduction zones. This is where our seafloor is being recycled at our active margins. Our geos are just our flat-topped mountains, and then we do have submarine canyons that we find on our active margins as well. All right, so once again, get used to seeing one of these diagrams and being able to label it for your assessment. And then we talked about the parts of a continental margin itself. So extending out from the areas of the continents, we do have land that extends out past to where we can actually see. So there is still a continental margin that stretches out until we hit oceanic crust. So our continental margin components that you do need to know is the continental shelf, the continental shelf break, the continental slope, the continental rise found on our passive margins, and then our abyssal plains. You do need to also understand the differences between active and passive margins. And South America is a prime example of this because on the western coast of South America, we actually have an active margin. And this is where we start to see that Nazca Plate being subducted below the continental crust. This is a subduction zone. Therefore, there is a geologic feature called a trench down at the bottom. There is no continental rise here. So where this trench is located is where we have a lot of earthquakes. We see a lot of geologic activity all up and down the western coast of South America where that active margin is. On the other hand, on the eastern coast of South America, we have a passive margin. So this is where our plates are coming together, not at a continental boundary. So we've got ourselves a shelf, a slope, and we actually have a collection of sediment down at the bottom referred to as the rise.